10 lost continents that prehistoric maps prove were real. Number 10. The Kerguelen Plateau and the forest at the bottom of the world. In the far southern Indian Ocean, roughly equidistant from Australia, Africa, and Antarctica, a slab of drowned rock larger than South Africa sits beneath the waves. Almost none of it breaks the surface. What little does is a scatter of volcanic islands so remote and so relentlessly battered by wind that 18th century sailors named the largest of them the Desolation Islands. Geologists today call the whole structure by a quieter name, the Kerguelen Plateau. The present-day plateau covers an estimated 1.2 million square kilometers of seafloor, rising some 2,000 meters above the surrounding ocean basins. Geophysicist Millard Coffin, whose research helped define what geologists call large igneous provinces, vast outpourings of volcanic rock unrelated to ordinary plate boundaries, has identified the wider Kerguelen system, including a related fragment called Broken Ridge that has since drifted more than 3,000 kilometers away on the far side of the Indian Ocean, as the second largest such province on the planet, with an original combined extent of roughly 2.3 million square kilometers. Seismic surveys through the plateau's southern crust returned wave velocities that do not match ordinary seafloor. They match continental crust, thick, layered, chemically distinct from the basalt that makes up a normal ocean bottom. Part of Kerguelen is not oceanic plumbing. It is a fragment of an actual continent, rafted apart from Gondwana as Australia, India, and Antarctica pulled away from each other roughly 100 million years ago. And once, part of it stood in open air. In 1946, Australian paleobotanist Isabel Cookson published a short paper in the journal Nature examining lignite, compressed low-grade coal, dug from shoreline outcrops on the Kerguelen Islands. Under the microscope, the lignite was full of pollen, southern beech, podocarp conifers, the unmistakable signature of temperate rainforest. Later fieldwork recovered fossil wood, cone scales, and leaf litter from the same tree families that still grow in the cool forests of New Zealand and southern Chile. That is the detail worth sitting with. A plateau now so cold and wind-scoured that its only modern inhabitants are a rotating shift of French scientists, resupplied by ship twice a year, once carried enough standing forest to shed its needles into peat. Somewhere beneath the gray chop of the Southern Ocean, root systems that anchored actual trees are compressed into rock, waiting for no one. The forest did not vanish in a single afternoon. Thermal contraction, the slow cooling and sinking of oceanic crust as it drifts away from the volcanic hotspot that built it, pulled Kerguelen's southern reaches underwater by the late Eocene, roughly 40 million years ago, with the rest of the plateau following through the Oligocene and Miocene. It was less a drowning than an extremely long, extremely cold exhale. No one claims the plateau was ever inhabited by humans. It drowned tens of millions of years before anything human existed to notice it. What is no longer seriously questioned is the plateau's dual nature, partly a sunken sliver of true continental crust, partly ordinary volcanic seafloor, fused together by tens of millions of years of eruption. A landmass on the scale of a mid-sized country once stood in daylight, grew a forest, and is now a research footnote at the bottom of the world. Kerguelen never had a human witness. The next entry did, and the people who watched it disappear left behind a name that has survived in local memory for well over 1,000 years. Number 9. Lyonesse and the land that drowned twice. Cornish folklore describes a kingdom called Lyonesse, stretching from Land's End to the Isles of Scilly, holding, depending on which telling survives, upward of 140 churches, fertile fields, and a wealthy population, swallowed by the sea in a single catastrophic night. In most versions, only one man escapes, riding ahead of the flood on a white horse. For centuries, historians filed the story exactly where they filed Atlantis, an evocative invention, a moral fable about pride and the sea, nothing a geologist needed to take seriously. Then, in 2009, storms off Mounts Bay in Cornwall stripped away enough sand to expose the stumps and root systems of an ancient forest, preserved in anaerobic mud below the modern beach. It was not the first such find. Fishermen and antiquarians had reported the drowned forest for over a century, but it was substantial enough to launch a sustained investigation that became known as the Lyonesse Project, combining archaeologists, geologists, and local historians. Radiocarbon dating placed the submerged trees at somewhere between 4,000 and 6,000 years old. Around the Isles of Scilly, the same research identified drowned field boundaries, cairns, and stone walls sitting on the seabed in patterns that only make sense as land management. Walls do not build themselves underwater. The islands, this evidence suggests, were not always dozens of small outcrops. For most of human habitation there, they were a single landmass, still called by an old Cornish name in local tradition, Enor, the Great Island. Here is the false summit. The obvious drowning, the slow, multi-thousand-year rise of post-glacial sea level that fed the earliest layer of the legend, is not the one that finishes the story. Enor did not fully fragment into the modern archipelago until sometime around the 5th or 6th century of the Common Era, well within reach of early medieval memory. The single catastrophic night detail in the Lyonesse legend does not fit 20,000-year-old glacial melt. It fits something far closer to living memory, an island whose final breakup may have been abrupt enough at the margins to be witnessed and retold, not merely inferred generations later. What makes this particularly haunting is the layering. Lyonesse is not one flood story. It is a folk memory of a genuinely multi-stage process, millennia of gradual submersion compressed by storytellers into a single dramatic night, attached to a landscape whose walls, forests, and field systems are still down there to check the story against. Few flood legends anywhere on Earth come with their own verifiable crime scene. Most researchers treat Lyonesse as folk memory of ordinary post-glacial coastal retreat, later dramatized into a single-night catastrophe, the way oral storytelling compresses slow processes into vivid moments. A minority push back on the single island reading entirely, arguing the Scilly Isles may have been a loose, tidally connected cluster rather than one solid landmass, even at the lowest points of sea level. What survives that disagreement is the seabed itself, field walls still in position under the sea, built by someone to keep livestock on dry land that is no longer there. Cornwall was not the only coastline that compressed a memory of drowning into scripture. Several thousand kilometers to the east, a much larger and much older civilization built an entire mythology on the same claim, at a scale the rock flatly refuses to support. Number 8. Kumari Kandam and the coastline the sea actually took. Tamil literary tradition, compiled across the first millennium of the Common Era, describes a vast lost continent called Kumari Kandam, stretching south from the tip of India across what is now open ocean, reaching in some tellings toward Madagascar and Australia. In this account, Tamil civilization did not begin on the Indian subcontinent. It began on a landmass now entirely underwater, home to advanced cities and the earliest Tamil literary academies, erased across a series of catastrophic floods. In the early 20th century, this literary tradition fused with an unrelated and by then discredited 19th century scientific hypothesis called Lemuria, a landmass some Victorian naturalists proposed to explain how lemur fossils turned up on both sides of the Indian Ocean, before plate tectonics supplied a far simpler answer. Tamil revivalist writers adopted Lemuria as scientific cover for Kumari Kandam, and the two ideas have traveled together in popular literature ever since. Modern plate tectonics leaves no room for either. There is no continental crust under the central Indian Ocean at the scale Kumari Kandam requires. No zircons, no seismic signature, no dredged granite. Whatever carried lemurs and their relatives across the Indian Ocean basin, it was not a walkable landmass. And it did not exist within any time frame human beings have been telling stories. But dismissing the whole tradition outright turns out to be its own mistake. The coastline off Tamil Nadu did change dramatically within the exact window when post-glacial seas were rising fastest. The ancient port city of Pumpuhar, near the mouth of the Kaveri River, a real Sangam-era trading hub named in surviving Tamil literature, appears, according to recent geoscientific reconstruction, to have been founded and relocated more than once as the coastline retreated. One reconstruction places an early version of the port some 30 kilometers further out to sea than its current ruins, from a period when local sea level stood roughly 50 to 110 meters below where it sits today. As the water rose through the early Holocene, the city is inferred to have shifted westward toward the land repeatedly, chasing a coastline that would not hold still. An underwater survey off Pumpuhar's coast, conducted by Tamil Nadu's State Archaeology Department as recently as 2025, is still mapping what that retreat left behind. That is not a lost continent. It is not even a lost region. It is a few kilometers of shoreline, relocated more than once, inside a window local memory could plausibly reach. The disagreement here sorts into three clean positions. Most geologists and archaeologists treat Kumari Kandam as myth outright, inflated from a real but small-scale sequence of coastal flooding around Pumpahar and the Palk Strait. Some Tamil historians take a middle position, arguing the surviving literary catalogues of lost Sangam academies preserve genuine institutional memory of earlier settlements now underwater, even if the geography attached to them was later exaggerated. A fringe reading still insists on a continent-scale landmass, unsupported by any seismic, sedimentary, or zircon evidence anywhere in the literature. What is not in dispute is the underwater masonry off Pumpahar, which the myth alone cannot explain and the geology alone cannot invent. Kumari Kandam was a continent built to fill the gap left by a real flood. The next entry is the reverse problem. A continent that was completely real, genuinely enormous, and is now so thoroughly forgotten that millions of people build their houses on top of it without knowing its name. Number 7. Greater Adria, the continent under your boots. Roughly 140 million years ago, a landmass on the scale of Greenland sat mostly submerged in a warm, shallow tropical sea, north of where Africa then stood. Limestone piled up on top of it for tens of millions of years, the way it does on any shallow seafloor rich in shell and coral debris, layer after layer, compressing into rock. Geologists call this vanished landmass Greater Adria, and until recently, almost no one could say with confidence where its pieces had gone. In 2019, geologist Douw van Hinsbergen of Utrecht University, leading a team that spent roughly a decade on the reconstruction, published the full tectonic history of the Mediterranean region in the journal Gondwana Research. Their conclusion? Greater Adria did not sink quietly, the way an island slips beneath open water. Beginning somewhere between 100 and 120 million years ago, it collided with the southern edge of Europe and was systematically scraped, folded, and shoved beneath the plate it struck, spinning counterclockwise as it went, jostled by every other plate converging on the same collision. The collision consumed almost the entire landmass, dragging it down into the mantle. What survived is a scattering of scraped-off fragments, plastered onto the underside of southern Europe like sediment caught in a sieve. Piece by piece, geologists have matched those fragments to specific mountain ranges. The Apennines, running down the spine of Italy, the Po Valley, the Apulia and Gargano peninsulas in Italy's heel, Istria on Croatia's coast, stretches of western Greece and the island of Crete, and the Taurus Mountains of southern Turkey. Here is the detail that separates Greater Adria from almost everything else on this list. Most lost continents are lost to the ocean, hidden underwater where no one walks. Greater Adria is lost in plain sight, underfoot, across some of the most densely populated coastline on Earth. Venice, Rome, Athens, and dozens of smaller cities sit at least partly on rock that once belonged to a landmass with its own separate tectonic identity. A continent people have been driving foundations into for centuries, without anyone thinking to ask the question. For a long time, the simplest explanation was also the accepted one. Those mountains were just Europe, folded upward by ordinary collision, nothing separate required. It took Van Hinsbergen's team roughly 10 years of matching paleomagnetic data, the fossilized compass directions locked into ancient rock, across the mountain belts of half a dozen modern countries to show the mountains were not simply European crust crumpled in place. They were the wreckage of something else, dragged in from the south and left behind. Not every detail of the reconstruction is settled. Van Hinsbergen's own model treats Greater Adria as one coherent microcontinent before the collision began. A minority of geologists reconstruct it instead as a looser cluster of blocks, more archipelago than single landmass, even before it reached Europe. A disagreement that echoes, oddly, the same question later asked about the next entry on this list. What both camps agree on is the outcome. Something large enough, coherent enough, to leave a name-worthy trail was consumed by the collision that built the Alps. Greater Adria shows what a real vanished continent leaves behind when it dies slowly. Mountain ranges, a name, millions of unknowing tenants. The next entry left behind almost nothing at all. No mountains, no mineral trail, nothing but one philosopher's account and roughly 2,500 years of people insisting it has to be real anyway. Number 6. The Azores and the island that was never Atlantis. Around 360 years before the Common Era, the Greek philosopher Plato wrote 2 dialogues, the Timaeus and the Critias, describing an island empire called Atlantis, larger in his account than Libya and Asia Minor combined, ruled by the descendants of the sea god Poseidon, and swallowed, according to the story, passed down through generations from an Egyptian priest to the Athenian statesman Solon to Plato's own family, in a single day and night of catastrophe, roughly 9,000 years before Solon's own lifetime. By that chronology, Atlantis was supposed to have gone under around the 9th millennium before the Common Era, deep in the last ice age. No geologist has ever found the wreckage, because the geology of the most popular candidate site makes the wreckage impossible. That site is the Azores, a cluster of volcanic islands roughly 1,500 kilometers west of Portugal, sitting directly on the mid-Atlantic ridge. Rock samples from the Azores are almost entirely young basalt, produced by the same seafloor spreading and hotspot volcanism that built Iceland. Oceanic crust, not the thick, ancient, granite-rich continental crust a sunken landmass of that scale would have to leave behind. There is no drowned shelf of continental rock anywhere near the Azores. There is only a chain of undersea volcanoes doing exactly what undersea volcanoes do. The official explanation was comfortable for exactly as long as no one checked the rock. Once dredged and sampled, the Azores told a different story than the legend, and the legend did not update. What actually happened in the Bronze Age Eastern Mediterranean, a separate region frequently blurred together with Atlantis in popular retellings, is a real catastrophe with real physical evidence. The eruption of the volcano at Thera, the modern island of Santorini, generally dated to somewhere in the 17th or 16th century before the Common Era. That eruption buried a Minoan settlement under volcanic ash, its own smaller and far better documented version of a civilization erased in a single geological event. And some researchers have proposed it as the kernel of memory that eventually calcified into Plato's story, garbled through centuries of retelling and relocated from the Aegean to the open Atlantic along the way. Calling that connection proven would be its own kind of myth-making. The mainstream position among classicists holds that Atlantis is Plato's invention, a philosophical device built to illustrate the dangers of hubris and imperial overreach, requiring no specific historical event to explain it. Some archaeologists argue the Thera eruption and the collapse of Minoan civilization supplied at least the raw emotional material Plato worked from, even if the details were reshaped past recognition. A persistent minority, never taken seriously by geologists, continues to argue for a literal sunken landmass in the Atlantic, usually pointing at the Azores, despite decades of seafloor sampling that has never once returned continental rock from the site. What remains undisputed is the mismatch between the story and the stone. An island as large as Plato described, sunk in a single night, would have left unmistakable geological wreckage. A scar plate tectonics cannot hide, the way it could never hide Greater Adria or the continent still to come on this list. Atlantis left no scar because Atlantis left no continent behind to leave one. It left a philosopher and roughly 2,500 years of people who preferred the story to the rock. Atlantis never had a body to examine, which is exactly why it survived this long as a myth. The next entry has a body. Geologists spent decades finding the wound in the seafloor before anyone could locate the rest of it.
Number 5. Argoland, the continent that went missing for 155 million years. Off the northwest coast of Australia, the ocean floor holds a scar called the Argo-Abyssal Plain, smooth, ancient oceanic crust, the kind that only forms where a piece of continent has rifted away and drifted off, leaving fresh seafloor to fill the space behind it. Geologists have known about this scar for decades. It has a distinctive, elongated shape, marking clearly where something large broke away from Australia and departed toward the northwest, roughly 155 million years ago. The problem was that nothing matching that shape had ever turned up anywhere. Continents that rift away are supposed to end up somewhere. They do not simply cease to exist.
For years, this absence carried an informal nickname among geologists, the case of the missing continent, or, more formally, Argoland, named for the abyssal plain that recorded its departure without recording its destination. In 2023, a team led by Eldert Advocaat at Utrecht University published the answer, after 7 years of fieldwork in the journal Gondwana Research. Argoland had not vanished. It had arrived, just not as a single continent. It had broken apart somewhere along the journey and scattered as a loose archipelago of separate microcontinental fragments, now buried beneath the islands of Southeast Asia and identified today within Southwest Borneo, Greater Paternoster, East Java, South Sulawesi, West Burma, and the Mount Victoria region of Myanmar. Advocaat's team coined a new term for the discovery, not Argoland, but the Argopelago, a shattered fleet of continental rafts rather than one coherent landmass.
That single reframing is what makes Argoland's story more than a straightforward "we found it" narrative. The scar in the Argo-Abyssal Plain is clean and continuous, as though one solid block departed in one piece. What actually crossed the ocean behaved more like a disassembled ship, hull sections, still recognizably continental crust, still carrying rock formations that trace back to a shared origin, no longer connected to one another by the time each fragment finished drifting and colliding, piece by piece, with the islands of Southeast Asia. Consider the implication for anyone living across modern Borneo, Sulawesi, Java, or Myanmar.
Anyone who has stood on volcanic soil, walked through a rainforest, or built a house on bedrock in those regions has a real chance of standing on a fragment of a continent that geology textbooks, until very recently, simply filed as unsolved. 155 million years unaccounted for, hiding in full view under some of the most densely forested, densely inhabited terrain on the planet. Advocaat's reconstruction, backed by paleomagnetic and structural data collected across the scattered islands of the Argopelago, ties every fragment back to one shared Gondwanan origin, displacing an earlier hypothesis that the fragments had arrived from separate, unrelated sources with no connection to the Argo-Abyssal Plain scar at all. The exact internal sequence of the original breakup remains active research. What is no longer disputed is the abyssal plain itself. The scar is real, it has an owner, and the owner has finally been named. Argoland took 7 years and a small international team to run down. The next continent required none of that patience. It was sitting in a bag of beach sand the entire time. Number 4. Mauritia and the grains of sand older than the island that held them. Mauritius is a young island, a little over 8 million years old, built entirely from basalt, piled up by a volcanic hotspot in the Indian Ocean. The same kind of process that built Hawaii. By every ordinary rule of geology, nothing on Mauritius should be older than the eruptions that made it.
In 2013, that rule broke. Researchers sampling beach sand on Mauritius identified grains of a mineral called zircon, a durable crystal that survives almost any geological process and can be dated with extreme precision by measuring the decay of trace uranium locked inside it. With ages clustering from around 600 million up to nearly 3 billion years old. That is not a rounding error. That is older than complex animal life, older than a breathable atmosphere, sitting in beach sand on an island whose own volcanic rock is, at most, a few million years old. The immediate objection was obvious. Wind, waves, or a passing ship could carry ancient zircon almost anywhere. Sand travels. In 2017, geologist Louis Ashwall of the University of the Witwatersrand in Johannesburg, working with colleagues, closed that loophole. Publishing in the journal Nature Communications, Ashwall's team reported Archean age zircons, again in the 3 billion year range, locked inside solid trachyte rock that had erupted from Mauritius itself roughly 6 million years ago. The ancient crystals were not resting on the beach. They were not wind-blown. They were baked directly into lava that had risen from underneath the island, meaning the magma feeding Mauritius's volcanoes had passed through something ancient and continental on its way to the surface.
That is the detail worth pausing on. An island younger than most species of shark alive today, built from lava that dragged fragments of rock roughly 500 times its own age up from the depths. A bucket pulled from a well, hauling up sediment from a far older lakebed underneath. Ashwall's team proposed a name for the source of those fragments: Mauritia, a microcontinent that once belonged to Gondwana, thinned and broke apart as Madagascar and India rifted away from each other roughly 60 million years ago. Most of Mauritia stretched and sank into oblivion during that separation, but not cleanly. Pieces of it, ranging from small fragments to blocks potentially hundreds of kilometers across, are now thought to lie scattered as buried continental crust across the floor of the Indian Ocean, hidden under younger volcanic rock the way a shipwreck disappears under decades of coral growth. Most researchers now accept, following the trachyte findings, that Mauritia is real, fragmented continental crust. Not a single lost landmass so much as a debris field. Some argue the fragments extend further than currently mapped, based on gravity anomalies detected across a wider stretch of the western Indian Ocean than has yet been directly sampled by drilling. What is no longer disputed is the zircon itself. Dated, solid, embedded in rock that erupted only 6 million years ago, carrying a signature nearly 3 billion years old that has no business existing anywhere near that island. Mauritia is a scatter of ancient crystal fragments across an ocean floor. The next entry is not a scatter. It is a fully formed subcontinent that supported human life, dense biodiversity, and thriving migration routes right up until the sea reclaimed it. Within a span, some of its descendants' cultures very nearly still remember. Number 3. Sundaland, the drowned twin of India. At the height of the last ice age, with enormous volumes of the planet's water locked into continental ice sheets, global sea level stood roughly 120 to 130 meters lower than it does today. Off the coast of mainland Southeast Asia, that drop did something almost nowhere else on Earth managed at the same scale. It exposed an entire subcontinent. Sundaland, built on what geologists call the Sunda Shelf, joined Sumatra, Java, Borneo, Bali, and the Malay Peninsula into one continuous landmass, which, at its fullest extent, is estimated to have covered an area comparable to the Indian subcontinent, with the shelf alone contributing an estimated 1.8 million square kilometers of newly exposed seafloor beyond the coastlines of the islands it stitched together. It was not empty. Its rivers, now submerged and mapped by multibeam sonar as ghost channels crossing the floor of the South China Sea and the Java Sea, drained a landscape of monsoon forest, floodplain, and coastline that supported tigers, elephants, rhinoceroses, and orangutans across its western half. The same fauna found on the Asian mainland today.
while a very different set of species, marsupials and monotremes, lived on the far side of a narrow, deep-water gap to the east. Naturalist Alfred Russel Wallace mapped that biological boundary in the 19th century without knowing why it existed. It exists because Sundaland's animals could walk to Asia. The animals on the far side of the gap never could, no matter how low the sea dropped. Sundaland's drowning was not gradual and even. Between roughly 20,000 and 6,000 years ago, sea level rose in surges rather than a smooth ramp. The most violent of those surges, a meltwater pulse dated to approximately 14,600 to 14,300 years ago, added as much as 16 meters of sea level in only a few centuries. Within perhaps 10 human generations, an ocean rose high enough to swallow river valleys that had been dry and walkable for the entire remembered history of the people living in them. The final stages of submergence, drowning the last connecting lowlands between the islands, are generally placed between roughly 8,000 and 6,000 years ago. What makes Sundaland more than a curiosity is what it implies about population. This was not sparsely used wilderness. The genetic and linguistic diversity found across modern maritime Southeast Asia today, the sheer number of distinct island populations, languages, and cultural traditions packed into a relatively small area, is difficult to explain without a much larger, more continuous ancestral population occupying a much larger landmass before the flooding fragmented it into isolated island groups. The drowning did not only erase land, it manufactured isolation, splitting one connected population into the scattered island societies whose descendants are still there. The archaeological consensus treats Sundaland as a drowned Ice Age subcontinent, populated by hunter-gatherer and early maritime communities who dispersed as the shelf flooded, feeding the region's later linguistic and cultural diversity. A more contested idea, floated by geneticist Stephen Oppenheimer in his 1998 study Eden in the East, goes further. That the flooding was severe enough to have seeded flood mythology across multiple Asian cultures, carried outward by migrants fleeing the drowning shelf. Most archaeologists remain unconvinced by the scale of that claim. What nobody disputes is the shelf itself, mapped and sampled and consistent with a subcontinent that drowned in exactly the time frame the sea level record demands. Sundaland went under gradually, in surges no single generation fully witnessed start to finish. The next flooding was different. It was watched, survived, and, this is the remarkable part, remembered, in stories still being told today. Number 2, Sahul, the continent the songs remembered. For most of the last 2.5 million years, through the long cycles of the Pleistocene ice ages, Australia, New Guinea, and Tasmania were not 3 landmasses. They were one. Geologists call this combined continent Sahul. At the peak of the most recent glaciation, with sea level roughly 125 to 130 meters below its current position, Sahul stood an estimated 30 to 40% larger than the 3 landmasses measure separately today. By some reconstructions, more than 11 million square kilometers, nearly a third larger than Australia, New Guinea, and Tasmania add up to now. Human beings reached Sahul by boat at least 50,000 years ago, and by some contested archaeological evidence, potentially several thousand years earlier still. One of the oldest deliberate sea crossings anywhere in the human story, since even at its lowest Ice Age sea level, the gap between the islands of Southeast Asia and Sahul was never a walkable bridge. It required boats, open water, and the willingness to sail toward a horizon with no land on it. Then, starting around 18,000 years ago, the ice sheets that had built Sahul began giving it back to the ocean. The process took thousands of years, but it was not gentle. The lowlands connecting New Guinea to the Australian mainland were the last to go. Rising water finally severed them through the Torres Strait roughly 8,000 years ago. The flooding Bass Strait cut Tasmania off from the mainland in a process most reconstructions place somewhere between 8 and 6,000 years ago. 3 landmasses that had been one for the entire span of human occupation split apart,
permanently inside a window some individual human lineages could plausibly have lived through across only a handful of consecutive generations. Sahul earns its place on this list for a reason no other entry can claim. In a 2016 paper in the journal Australian Geographer, geographer Patrick Nunn of the University of the Sunshine Coast and linguist Nicholas Reid of the University of New England examined Aboriginal Australian oral traditions describing coastlines being swallowed by the sea. They gathered accounts from 21 locations spanning the entire Australian coastline. Stories of specific bays, islands, and hunting grounds the tellers insisted had once been dry land. Nunn and Reid did something no one had systematically tried before. They took each story's geographic details literally, calculated how far the sea would have to drop for the described landscape to actually exist, and checked that depth against the known curve of post-glacial sea level rise around Australia. The stories matched, not vaguely, but precisely enough to date individual accounts to specific inundation events between approximately 7,200 and 13,000 years ago. Some of these narratives, if the dating holds, represent close to 13,000 years of continuous oral transmission, a testable, falsifiable claim checked against physical sea level data and found to hold. Consider what that implies. If a story can survive intact enough, generation after generation, for its language to carry a literal coastline across 10,000 years without collapsing into pure metaphor, then the line between myth and data is far less stable than the word myth usually suggests. You may be separated from someone who watched Sahul's coastline retreat by nothing more than several hundred generations of people who simply refuse to let the story change enough to become false. The debate here is not about whether the sea rose, that part is uncontested, but about how literally to read the transmission itself. Most researchers accept the correlation between story and sea level record as strong evidence of genuine deep-time oral transmission. Some linguists caution that a handful of matches could arise from coincidence, or from flood narrative tropes common to many unrelated cultures, rather than truly unbroken memory. A minority view goes further than Nunn and Reid themselves proposed, suggesting some tellings may encode not just coastline change in the abstract, but the specific, witnessed experience of watching kin, hunting grounds, or burial sites vanish beneath rising water within a storyteller's own lifetime. Coincidence across 21 independent locations, matched against 21 independently calculated sea level dates, is possible. It is not the way most working scientists would bet. Sahul proves that a spoken story can outlast a coastline by 10,000 years without breaking. The final entry on this list proves something even larger, that an entire continent can outlast human memory altogether, hiding in full view under an ocean, until modern geology finally caught up to what the rock had been saying the whole time. Number 1. Zealandia. The eighth continent hiding in plain sight. Picture a world map from 1990, the kind bolted to a classroom wall. 7 continents, evenly colored, their outlines treated as settled fact. New Zealand sits on that map as a pair of small, isolated islands, a footnote southeast of Australia, geologically unremarkable. That map was wrong. Not in a small way. It was missing something on the scale of the Indian subcontinent. For most of the last 500 million years, the landmass now called Zealandia was locked into the southern supercontinent of Gondwana, wedged against what would become Antarctica and Australia. Beginning around 85 million years ago, rifting tore it free. As the Tasman Sea and the Southern Ocean widened between the pieces, Zealandia drifted off alone, thinning and stretching as it went, a process that leaves continental crust weaker and eventually lower than crust that stays thick and undisturbed. That thinning caught up with it. Through the Oligocene, in a phase geologists sometimes call the Oligocene drowning, roughly 25 to 23 million years ago, the thinning dragged most of Zealandia's already lowered surface under the waves for good. What geologists still debate is not whether this happened, but how completely. Most reconstructions hold that Zealandia was reduced to a scatter of small islands at its lowest point, with New Zealand's modern landmass representing only the parts that stayed emergent, or were later pushed back up by renewed tectonic activity along the Pacific's Ring of Fire. Some researchers argue the drowning was total and brief. Every scrap of Zealandia below the water at once, before Pacific plate collisions began thrusting the southern Alps and other modern ranges back into the sky. The disagreement matters for biology as much as geology, since it changes how New Zealand's unique plants and animals could have survived the drowning at all. For over a century, this was treated as a regional New Zealand curiosity, not a planetary one. That changed on the 10th of February 2017, when GNS Science geologist Nick Mortimer and 10 co-authors, 9 from GNS Science, joined by colleagues from the Geological Survey of New Caledonia and the University of Sydney, published Zealandia, Earth's Hidden Continent, in the journal GSA Today. Their argument was procedural rather than emotional. Geologists already had 4 working criteria separating a true continent from an ordinary microcontinent or a stretch of unusually elevated seafloor: high elevation relative to the surrounding ocean floor, a broad range of igneous, metamorphic, and sedimentary rock types, distinctly thicker crust than the abyssal basins around it, and boundaries well defined enough over a large enough area to rule out microcontinent as a label. Mortimer's team tested Zealandia against all 4 and found it passed every one. The first time anyone had made the case with a complete geological argument rather than a suggestive map. Here is the scale that argument rested on. Zealandia covers an estimated 4.9 million square kilometers, nearly the size of the Indian subcontinent, of which roughly 94% sits underwater. Only about 5%, New Zealand's North and South Islands, New Caledonia, and a scatter of smaller islands, breaks the surface. Geologists needed a genuinely new category to describe it, because the standard label for a piece of drowned continental crust tops out at a fraction of Zealandia's size. Not a shoal, not a large microcontinent, a continent, by every criterion that mattered, that happened to be sitting underwater. At the same time, roughly 1,500 kilometers to the north, geologists reconstructing New Caledonia's ancient rock record found the same continental basement, the same rifting history, the same drowning timeline, independent confirmation from a different corner of the same landmass, without which Mortimer's team could not have defined Zealandia's true extent at all. The core geological case is now essentially settled. What continues is refinement, not doubt. In 2023, GNS Science released the most complete bathymetric, geological, and tectonic map of Zealandia ever produced, describing it as the first continent mapped in its entirety, coastline to abyssal edge, in a single coordinated survey. New Zealand and the surrounding Pacific margin remain seismically and volcanically active today, part of the same Ring of Fire system that periodically pushes slivers of Zealandia's crust back above the waterline, even as the rest of it stays submerged. A reminder that the line between risen and drowned on this particular continent has never actually stopped moving. Weigh the implication of a discovery this large arriving this recently. If an entire continent, not an island, not a reef, not a shoal, but a landmass on par with the Indian subcontinent, could sit unmapped and uncategorized long after human beings had photographed the surface of Mars, then the 7-continent model, taught in classrooms for over a century, was never a finished description of the planet. It was a provisional sketch, drawn from whichever parts of Earth's crust happened to be dry at the moment someone decided to start counting. Zealandia stands as evidence that a continent does not require dry land to be real, only rock, criteria, and someone rigorous enough to apply them. It does not care that 7 fit neatly onto a school poster, or that geography textbooks are expensive to reprint. The same rifting, thinning, and drowning that pulled Zealandia under is still active geology today. Running along plate boundaries most of the 8 billion people currently alive have never had reason to think about. Until, on a map that has already been proven wrong once, it quietly redraws the coastline again. If you want to see more videos like this, Click the video on screen now and make sure to subscribe.